we are, coming from West Virginia. Hope you're doing well. Here we go. Joke of the day. I know some people hate math, but you've got to admit, decimals have a point. All right, let's go ahead and get into where we left off. We're still dealing with quadratic equations. Thank you, JD.
Bye.
We're still dealing with quadratic equations, and we've identified what a quadratic equation looks like. Remember, it's an equation where the variable has what kind of power? Dos. Absolutely. So second power on our equation indicates that it's quadratic. We've got 4 methods for solving. We've looked at 3 of them so far. First method is factoring. Recall, factoring is based on that zero product principle that says when I got 2 things multiplied together to get a 0, what has got to be true about one of them? Bingo, you're right. One of them has got to be the 0. So we factor our equation, set each one of those factors equal to 0, and solve it from there. Method of factoring, I'm going to level with you. Method of factoring is the easiest way to do this if your equation will factor. I know everybody argues and says, oh, no. You've been holding out on me. That quadratic formula is the easiest way to go. But I'm here to tell you that that most people can factor it faster than they can calculate on a quadratic formula. So I'm telling you, I will argue with you to my grave that if it factors, that's the easiest way to go. Now remember, the square root property also, believe it or not, is faster than quadratic formula. The square root property says if I have a quantity squared and I do not have a first power term, all I gotta do is take the square root of both sides. Bam, I'm done. So square root property is a quick and easy way to go about it if you do not have a first power term. Completing the square, a little bit longer, a little bit more difficult, but remember we talked about it's based on this square root property that if I can create that quantity squared, I'm gonna take the square root of both sides. What creates a quantity squared is having identical parentheses. So I'm going to try to create the identical parentheses. I'm going to look at what I started with, and if it will not factor into identical parentheses, I'm going to get rid of what's preventing that. Frequently, it's if I have a first coefficient that's not a 1, so I'll divide through by that coefficient, every single term by that coefficient. Frequently, it's the constant term that doesn't have a variable with it. I'll slide it to the other side. And then I will force that identical parentheses. The way that I force the identical parentheses is I take that middle coefficient, I cut it in half and square it. That's what I add to both sides, and then it factors beautifully. Do not take that middle coefficient and cut it in half and square it until you have slid out your constant term and until you have divided everything by that front coefficient. But that's a quick summary of the other 3 methods. So we are now down onto the last of the 4 methods, the quadratic formula. And like I said, everybody says at this point, oh my gosh, you were holding out on me. This is the easiest way to go. Actually, it's not. But the quadratic formula says, okay, when I have a quadratic, there's my second power term on my x. That's what makes it quadratic. And it's set equal to 0. That's the critical part of this, is it has got to be set equal to 0. When it is, to figure out x, all I have to do is use this formula. Now notice this is a negative b, which is that middle coefficient, but it's the opposite of that middle coefficient. So if my middle coefficient's positive, this is going to be a negative b. If my middle coefficient's negative, this will be a positive b. So it's the opposite of the middle coefficient. Plus or minus, I need both plus or minus, big old square root. Underneath that big old square root is a b squared minus 4ac. The whole thing is divided by a 2a. In this quadratic formula, the a, the b, and the c all come from these coefficients. The coefficient of the x squared term is your a, the coefficient of the x to the first power term is your b, and this constant that has no variable with it, that's your c. Plug those numbers into this quadratic formula and then just follow order of operations in order to simplify and evaluate that expression. I want to point out a couple of things that people tend to mistake on this quadratic formula. One of the common things that's left off is this opposite right here, this negative. You always want the opposite of whatever that sign is. Another common mistake that people do is they forget the squared part on this b. It is b squared. Another common mistake is they forget that this is a minus 4ac and instead they'll make it a plus 4ac. The other very common mistake is this 2a. They will only divide it to this back part here. But you need to understand that the entire expression up on that numerator has got to be divided by the 2a, all of it. Now, before we actually start using the quadratic formula, I'm going to show you one of the really awesome features of the quadratic formula. It's called the discriminant. This discriminant is what's underneath the radical right here. The discriminant is that b squared minus 4ac. The nice thing about the discriminant is that without solving this, without evaluating your quadratic formula, you can very quickly find out what types of roots that you're going to have within your graph. Remember, the roots are where your graph crosses that x-axis, your x-intercepts, also called your solutions, also called zeros, but those roots are where it crosses. So very quickly, you can figure out how many times it crosses and what types of numbers you're going to be dealing with whenever you cross. So it tells you the number and types of solutions that you're going to have, how many of those solutions you'll have, and what they will look like. So let's flip this over and let's take a look at how that discriminant works, and then we'll actually work with that quadratic formula. So I've got this chart here that summarizes how the discriminant works. I've got my quadratic formula written down here again just to be able to utilize it. You don't necessarily have to write it down again, but I need to be able to refer to it, so I wrote it again. But notice in the chart, this is saying, here's my discriminant, and I'm going to say that that discriminant, remember, that's what goes underneath the radical. That discriminant is greater than 0. Well, what types of numbers are greater than 0? Yeah, positive numbers. So my discriminant is going to be positive, and it's a perfect square. So when I take a look at the idea that this number that goes underneath this radical is positive, and it's a perfect square. Now, perfect squares are numbers that you can find the square root of. So for instance, 9 is a perfect square, because what's the square root of 9? Yeah, 3. 25 is a perfect square, because what's the square root of 25? Yeah, 5. So in other words, this here is saying the number that goes underneath this radical is a positive number, and I can find the square root of it. So what's going to happen then is I'm going to take this negative b, I'm going to add that number, I'm going to subtract that number. So I will end up with two answers, because I'll have negative b plus, I'll have negative b minus, so I'll end up with two answers, and they are going to be two rational roots. Rational because, remember, what does rational mean? Not rational dude, even though that's really perfect right here with all the surfing. It doesn't mean rational dude. What it means is can be written as a fraction. So I'm going to have negative b plus that perfect little number divided by this. That's a fraction. Negative b minus that perfect little number divided by this. Those are going to be two rational numbers for my answers. So in terms of my graph, what's going to happen is it's going to cross in two spots. They might be fractions, but they're going to be some pretty decent numbers to work with. Now this case says, okay, my discriminant is still going to be positive. So what goes underneath this radical is still going to be a positive number, but it's not a perfect square. Like say for instance a 7. I don't know what the square root of 7 is. It's some wild and crazy decimal. Same thing for like an 11 or a 13 or 41. All of those are not perfect squares. And in fact, it doesn't even have to be a prime number. Say for instance a 12. 12 is not a perfect square. It does split up as a 4 and a 3, and the square root of 4 is 2. So square root of 12 does simplify into 4 times 3, 2 square root of 3, but the idea is this is still going to be a wild and crazy decimal. So my point is, if that number that goes underneath the radical is positive, but it's not a perfect square, not a number that I can, bam, get the square root of it and get rid of the square root, then what's going to happen is I'm going to have a wild and crazy decimal here. And in fact, it'll be an irrational number, because it'll be a decimal that goes on forever and never repeats, never ends. But I will have two of those, because I'll have negative b plus that crazy decimal, negative b minus that crazy decimal. So I will still have two roots, but there'll be two irrational roots, because that radical will give me irrational numbers. But I will have two. So in my graph, it'll definitely cross in two spots. It's just those two spots that it crosses are going to be irrational numbers. Crazy decimals that go on forever and ever and ever. They never repeat, they never end. Now, let's take a look at this case. So what happens here is my discriminant is a 0. So that means what I'm putting underneath the radical is just a 0. That's it. It's 0. So when you put a 0 under here, what's the square root of 0? What would you multiply by itself to get a 0? Yeah, just a 0. So that means all of this is now gone. Every bit of it is gone. And you just have a negative b plus or minus nothing. So basically just a negative b over a 2a. Now that is rational because it's a fraction sitting right in front of your face, but how many fractions do you have? Just one, absolutely. So I have one rational root. So what happens in this case is, again, this is telling me where is this thing going to cross that x-axis. In this case, it's only going to cross in one spot. Now, it may sit over here, it may sit over here, it may actually be right here. But my point is, my graph will just kind of bounce down. It'll kiss it and bounce right off. It'll just touch it and bounce on. It will not dip below it. Or, I talked to you before about the parabolas don't always flip up. Sometimes they flip down. So if it flips down, then what's going to happen is, once again, it's just going to kiss it and it's going to bounce right off and it'll flip this way. And again, in this case up here where it crosses in two spots, if it flips down, it'll cross like this. But my point is that it's only crossing in, it crosses in two spots here. It only hits in one spot there if my discriminant is a 0. Now, let's look at this last case right here. This says the discriminant, what is underneath that radical, is not positive anymore. It's less than 0. What types of numbers are less than 0? Yes, negative numbers. So I'm going to put a negative underneath here. Now, you know what happens when you have a negative underneath the radical, because we talked about that before. When you have a negative underneath the radical, remember, that's an imaginary number. You have to take the I out. So what happens is you take that I out of here, you're going to have a negative b plus that imaginary number, not irrational, but imaginary. You're going to have negative b minus that imaginary number, but that still means you have 2. It's just you're not going to have rational roots or irrational roots. You're going to have imaginary roots, but you still have 2. 2 imaginary roots. But again, the idea is, okay, how is this going to cross that x-axis? If it's imaginary, where are you going to put an imaginary number on that axis right there? And you're absolutely right. You can't. I know you're going, I don't know. But you're right. You're not just not knowing. You're absolutely right. There's no place to put it on this x-axis. That means that my graph, instead of hitting it twice, instead of hitting it, kissing it and bouncing off, it's not even going to cross. So if it flips up, it'll look like that, and if it flips down, it'll look like this. So this is the beauty of the discriminant. It allows you to figure out, without working the whole quadratic formula, it allows you to figure out the number and types of solutions that you're going to have, so that you just get this idea of what the graph is going to look like. So let me give you some examples. Flip this thing around. Oh. And bear with me a second, we're having some trouble with the equipment. There we go. All right, let me erase all of this. Enjoy the scenery. If only West Virginia did look like this. I can pretend, right? I can pretend. All right, so let me get you some examples. So, in each of these examples, we're going to work with that discriminant, and then we're actually going to work with our quadratic formula. So, in each, we are going to determine the number and types of solutions. There's some background music for us. Pardon my phone. Then we're going to solve each. So in order to determine the number and types of solutions, what we have to do, remember, is use that discriminant. So in order to use that discriminant, remember, it looks like this. B squared minus 4AC. Now, in order to figure out what the A, the B, and the C are, I need to make sure that this is set up so that it's equal to 0. It is. So once I know that it's set up equal to 0, then I can identify my A, my B, and my C. My A is going to be the number that's in front of the x squared term. So in this case, my A is going to be 2. My B is the coefficient of the first power term. So in this case, my B is going to be a -3. And my C is going to be this constant that's in the back that has no variable with it. So my C is going to be a -5. So now that I've identified my A, my B, and my C, I can plug them into this discriminant so I can figure out the number and types of solutions that I'm going to have. So I'm going to plug in that B as a -3. I'm going to plug in that A as a 2. And I'm going to plug in that C as a -5. And now I'm going to follow order of operations. Order of operations says that I need to do my exponents before I do multiplication and before I do subtraction. So exponents here, -3 squared is a 9. And after I do exponents, remember, comes multiplication according to PEMDAS, order of operations. So I'm going to do all this multiplication back here. 4 times 2 is 8. 8 times -5 is a -40. So I've got minus a -40. And subtracting a negative is really adding a positive, and so I've got a 49 as my discriminant. Remember, this is the number that's going to go underneath the radical in my quadratic formula. So thinking about the fact that this is going to go underneath a radical, I'm going to end up taking the square root of it. Now that's not my discriminant, that's not my answer. I'm just getting us to think about what happens here. Yeah, I can take the square root of 49 because what would you multiply by itself to create a 49? Sure, a 7. So that means that whenever I take the square root of that 7, when I start utilizing my actual quadratic formula, which we'll go ahead and put it up here, my -b plus or minus square root b squared minus 4ac all over 2a, then what happens here is that 49 is going to go underneath here, and so I'm going to get a -b plus 7, -b minus 7, and I'm going to divide each one of those by a 2a. So I'm going to get 2 rational roots because they're going to be able to be written as a fraction. In other words, it's not wild, crazy decimals. So this indicates to me, once I get that 49, thinking about that that's what goes underneath there, then that tells me I'm going to get 2 rational roots. So now that I know I'm getting 2 rational roots, I'm going to say, okay, let's figure out what they are. So I'm going to take that 49, I'm going to put it right in here, and I'm going to plug in my numbers for the rest of it. So once I go with my quadratic formula, and folks, if you've got something you've got to memorize, just write it down every single time you use it. You'll memorize without even trying. I say this all the time, but it's absolutely true. I never had to have flashcards. I never had to write stuff down, formulas down on a paper and stare at that paper and memorize it. Because if you write this thing down every time you use it, you can't help but memorize it. Now, there's lots of jingles and songs that you can use to memorize your quadratic formula. In fact, I've got one that kind of goes with this. It kind of goes to the Macarena, and it goes -b plus or minus square root b squared minus 4ac all over 2a. Hey, quadratic formula. I know, I can't sing. It's all right. But anyways, look for that video to come out pretty soon because I'm so ready to film that video. I'm so excited about this. Anyways, lots and lots of jingles and songs that you can use to memorize it. But I'm telling you, just write the stupid thing down. Every time you use it, you'll memorize without even trying. So I've written my formula down. I'm going to plug my numbers in. Remember, this is the opposite of b. My b is a -3. So when I plug that in, I want the opposite of that -3. Plus or minus my discriminant. Remember, I already did all of that, and it came up as a 49. All over 2 times my a of 2. Now, according to order of operations, well, first off, I know the opposite of -3 is just a 3. And I know that the square root of 49 is a 7. And I know that 2 times 2 is a 4. So I have 3 plus 7 divided by 4, and I have 3 minus 7 divided by 4. So I'm going to erase this right here and kind of try to squeeze that up there because I'm starting to run out of room. So this is going to slide right up here. So remember, what I have is 3 plus 7 divided by 4, which gives me 10 divided by 4. And always simplify a fraction if you can, so that gives me 5 halves. And then I also have a 3 minus 7 divided by 4. And 3 minus 7 is a negative 4 over 4. Oh my gosh, I'm really running out of room. Let me go ahead and erase my quadratic formula here. And negative 4 divided by 4 will give me a negative 1. So there's my two answers, 5 halves and negative 1. These are the two numbers that when I plug them back in there and do all that order of operations, I'm going to come up with a 0. But remember, more than that, these are also the two spots where it will cross that x-axis. These are my two roots. Now think about this. Remember, back here we said I need to come up with 2. 1, 2. So far, so good. I need to come up with rational numbers. There's a fraction sitting right in front of my face, and if I put this over a 1, it's a fraction. So this makes sense. It follows what I expected to happen. So there's one example of using the discriminant and being able to use the quadratic formula. Let me give you another example. Matter of fact, I got 3 more just to make sure we're really good at this stuff. So let's flip this back around, and I think at this point we don't need this chart anymore. So let me get that chart out of the way, and we can run with those 3 more examples that I've got for you. All right. So in this example, we've got 6x squared minus x minus 3 equal to 0. And it's the same directions that say I need to find the number and types of solutions, and then I need to figure out what those solutions actually are. So if I'm going to figure out the number and types of solutions, remember that means I need that discriminant. The discriminant, once again, is that b squared minus 4ac. So I need to be able to identify my a, my b, and my c. I can only do that when this is set equal to 0. It is, so I'm good. I'm ready to go. When it's set equal to 0, that a is going to be the number that's in front of the x squared term. So my a is going to be 6. My b is going to be the number in front of the first power term. So in front of it, remember, is a negative 1. And my c is going to be this constant that's sitting in the back. In this case, it's going to be a negative 3. Now I can take all 3 of these numbers and plug them into that discriminant so I can figure out the number and types of solutions that I've got. So my b is a negative 1. My a is a 6, and my c is a negative 3. Now I'm going to follow order of operations, which says I need to do exponents first. So a negative 1 squared is 1. And at that point, I need to do that multiplication. So a negative 4 times 6 is a negative 24. Negative 24 times 3 is going to be a positive 72. And now 1 plus 72 is a 73. Keep in mind, that's what's going underneath the radical. So I'm going to ask myself, okay, when I'm looking at that quadratic formula that looks like this, negative b plus or minus square root b squared minus 4ac all over 2a. Hey, quadratic formula. Anyways, this is what's going underneath that radical. So ask yourself, can you think of a number that you can multiply by itself to create a 73? No, not at all. So I'm not going to get a perfect square out of there. Matter of fact, this is going to be an irrational number, that wild and crazy decimal that goes on forever and ever and ever. It never repeats. It never ends. So I'm going to get a negative b plus that crazy decimal, a negative b minus that crazy decimal. How many answers are you getting? Yes, definitely 2. But 2 of what types of numbers? Crazy decimals that go on forever and ever and ever, never repeat, never end. Those are irrational. So I'm going to get 2 irrational roots out of this. So that tells me the number and types of solutions. So what I'm going to do now is I'm going to figure out, okay, what are those solutions? So I'm going to plug my a, my b, my c into this quadratic formula that I've already written down because I'm going to memorize it without even trying. This is the opposite of b. My b was a negative 1, so I want the opposite of a negative 1. Plus or minus square root of, I've already figured out my discriminant's a 73. All over 2 times a is a 6. Now, order of operations says, well, first off, this is just a 1. So I've got x equals 1 plus or minus square root of 73, which I don't know the square root of 73. I'm going to simplify the radical if I can, but that radical won't simplify. 73 is prime. It only breaks up as a 73 and a 1, so that doesn't help at all. If you can simplify the radical, definitely do that, but this won't. And then underneath in the denominator, 6 times 2 is going to be a 12, so there it is. Now, there's nothing more that I can do with it. I can certainly separate things out if I really want to. A lot of people don't like this format. This is perfectly fine right here, but a lot of people don't like it combined up like that. So you can take this denominator, you can separate it into each of those numerators. So I could, if I wanted, call it a 1 over 12 plus or minus a square root of 73 over 12. And these two mean the very same thing. But you certainly don't have to do this. You can leave it underneath one, or leave it as one denominator. But you can see that, yeah, I'm getting that irrational number. I've got 1 plus that irrational number divided by 2, which is still going to be an irrational number. 1 minus that irrational number divided by, not 2, but 12. Still going to be an irrational number. So I definitely have 2 irrational roots as my answers. So this makes total sense here. All right. 2 more examples, again, just to make sure that we're solid with this. It makes total sense and we know exactly what we're doing. Okay, in this next example, same directions. I'm going to find the number and types of solutions, and then we'll figure out what those solutions actually are. And I think you know where I'm going with this stuff, and I'm going to try to give you an example of every type that you can see. So in this one, I'm going to have a 9x squared plus a 12x equal to a negative 4. Now remember, my discriminant, that b squared minus 4ac, I need to be able to identify my a, my b, and my c in order to figure out the number and types of solutions. But recall, I can only do that when this is set equal to 0. It's not set equal to 0. So the first thing I got to do to be able to identify my a, my b, and my c is get rid of that, slide that negative 4 to the other side so that it's set equal to 0. Now when I slide that over, I'm going to add it to both sides. So I'll get a plus 4 over here, and when I add 4 over here, I get a 0. Aha, I'm good to go now. Now I can figure out what my a, my b, and my c is. Remember, a is in front of the x squared term, b is in front of the first power term, and c is that constant that's in the back that has no variable with it. So now I can take these 3 numbers and plug them into my discriminant. So b squared would be 12 squared, a is a 9, c is a 4. According to order of operations, I do my exponents first. So I get a 144 here, and now I'm going to do that multiplication next. So 9 times 4 is 36. 36 times 4 is a 144. And now when I take 144 and subtract 144, I get a 0. Remember that this is what's going to go under the radical in that quadratic formula. So here's my quadratic formula. Again, I'm going to write it down every time so that I memorize it without even trying. Negative b plus or minus square root b squared minus 4ac all over 2a. Hey, quadratic formula. Oh, I can't wait to make that video. Anyways, now all these numbers are going to go in there. But remember, that discriminant's going to sit right here. And when I take the square root of 0, it's just 0. So like we said before, I'm left with this right here. So that means I'm only going to have one solution, and in fact it's going to be one rational root because that's a fraction sitting right in front of me. So I'm going to get one rational root. And so now I'm just going to figure out, okay, what is that one rational root? So I'm going to plug my numbers in, keeping in mind that this is the opposite of b. b was a 12, so it's the opposite of that 12. Now remember, this discriminant, I figured it out to be a 0. And now 2 times a is a 9. So since this is square root of 0 is just 0. It's totally gone. So that means I have a negative 12 over 2 times 9 is 18. See, yeah, that's one answer, one root, and it is a rational number. Now always simplify a fraction if you can. This will simplify because 6 will go into both. 6 goes into 12 twice, 6 goes into 18 3 times. There it is. So remember, and it makes sense, this lines up with what I said would happen, but remember, not only is this the one and only number that I can plug in here and here, do all this order of operations over here and come up with a negative 4, this is also where it's going to cross that x-axis. So remember what happens here is, when I look at that graph, it's going to hit a negative 2/3 on that x-axis, and what's going to happen is it's going to come down, it's going to kiss it and bounce right off. And it's going to look like this. So, that's the third example of being able to use the discriminant and being able to use the quadratic formula. Let's look at one last example. last one. And like I said, I think you know where I'm going with this stuff, but I do like for you to see everything so that you understand how it works and feel comfortable with it when you get to practicing it. So this last example is going to look like this. And I have the very same directions. Those same directions say, okay, I need to figure out the number and types of solutions. That requires the discriminant, b squared minus 4ac. And after that discriminant, I'm going to figure out what the solutions actually are. But remember, in order to identify that a, that b, and that c, I need to get this all set equal to 0. I have a couple of options. One option is to take this x squared and slide it over here. Or the other option is to slide both of these over here. Most people like for this front coefficient, the x squared term, to be positive. So most people slide both of these over here. But it really makes no difference which way you go. And I'll prove that to you. So if I slide both of these over here, just going with what most people do, I'll add the x, I'll add the 1, and that'll set it equal to 0. So now I can identify my a, my b, and my c. The a is right here in front of the x squared term, so it's a 1. The b is right here in front of that first power term. It's also a 1. And the c is this constant in the back. Whoa, it's also a 1. They're all 1s. Well, that'll be interesting. So now I'm going to plug all those numbers into my discriminant and figure out the number and types of solutions. So everything is a 1. Order of operations says let's do these exponents first. 1 squared is 1. And at this point I'm going to do that multiplication. 4 times 1 times 1 is 4. And 1 minus 4 is a negative 3. Remember, this is what's going to go underneath the radical in that quadratic formula. My negative b plus or minus square root b squared minus 4ac all over 2a. Hey, quadratic formula. But this is what goes underneath that radical. So you can see, yeah, when I put a negative underneath there, that means I got to drag that I out, meaning I'm going to have an imaginary number. So I'm going to take that negative b, I'm going to add the imaginary number, negative b minus the imaginary number. So I'm going to have 2 roots, definitely, but I'm going to have 2 imaginary roots. And so now that I figured out what types I've got and how many I've got, I'm going to actually see what they are. So I'm going to plug those numbers into my quadratic formula. So everything is a 1, but I want the opposite of that 1, so I want a negative 1. Plus or minus square root, we already figured this out to be a negative 3, all over 2 times 1. Now remember, when there's a negative underneath the radical, that indicates that I've got to drag that I out of there and then simplify the radical that's left. So when I drag that I out, I get a negative 1 plus or minus I squared of 3. Simplify that radical if you can. Look for perfect squares and pairs. Don't know the square root of 3, can't split it up into anything that's useful. It's just a 3 and a 1, so that doesn't help. And underneath 2 times 1 is 2. Now remember, if this 2 will divide into here and here, go ahead and do it. Certainly can't divide it into here. Remember that whole idea of, we looked at those roots and radicals, and our quotient rule said, if these are both underneath a radical, then you can go ahead and take 3 divided by 2. But they're not both underneath a radical, so I really can't do that. So it won't go into both, and if it won't go into both, just leave it alone. This is a perfectly good answer right there. But like I said before, some people don't like it combined. You can separate it, but that means that 2 has to divide into each term. So it'll divide here, and it'll divide here. These mean the very same thing. It's just your personal preference as to how you want to write it. But please understand, it is 2 answers. You've got a negative 1/2 plus I squared of 3 divided by 2, a negative 1/2 minus I squared of 3 divided by 2, or in this case, negative 1 plus I squared of 3, whole thing divided by 2, or a negative 1 minus I squared of 3, whole thing divided by 2. My point is this, you have 2, and you have imaginary roots, so it lines up with exactly what we said would happen. And again, really important to understand that in terms of this graph right here, where is it going to cross this x-axis? It's not, because I can't put an imaginary number on here. So it's not even going to cross at all. It's either going to flip up or flip down. This one happens to flip up. I'll show you soon how that works. But it's not going to cross at all. So this is what happens whenever you've got a situation where you need to figure out the number and types of solutions, and whenever you need to figure out what those solutions are using that quadratic formula. Now, I did want to point out to you, remember I said it doesn't matter if you slide all this over here or slide all this over here. Let me show you what would happen if you decided to slide it all over to the other side. This will be quick and easy. So what would happen in that case is I would get a 0 on this side. When I slide this over, it becomes negative x squared minus x minus 1. And then what happens is all of these become negatives. So my a is a negative 1, my b is a negative 1, and my c is a negative 1. What happens then is, in terms of this discriminant, I will get a negative 1 squared, but that's still 1. I'll get a negative 1 here, negative 1 here, but a negative times a negative times a negative is going to still be a negative. So I'll still get a negative 3 underneath that radical, so it doesn't change this part at all. Now here, the opposite of a negative 1 is a positive 1. That will change this part, and this part, and this part, but down here, 2 times in this case, now it'll be a negative 1, will give me a negative 2 down here. So what happens is, now I get a negative 1/2, which is what I had before. And if I take a positive divided by a negative, I get a negative. If I take a negative divided by negative, I get a positive. So I still get that plus minus that's in there. So I still get this kind of result here, which frankly means that I could multiply this denominator by a negative 2 to get rid of the negative in the denominator, multiply every term up here by a negative, which would put a negative there, change that to a minus, change that to a plus, I still get my plus minus, so I'm still getting the very same answer. That's why I said it doesn't matter if you slide it over here or over here, it's all going to work itself out. It'll be perfectly fine. So, hopefully now you understand how the discriminant works in terms of being able to figure out the number and types of solutions based on that discriminant being underneath the radical and what it means to have that type of number underneath the radical. And then hopefully it also helps you to see, now that I get that discriminant put in there, I can solve my quadratic formula and I can figure out how it's going to cross the x-axis. So, have a great day.